right, lesson 1-2. These are the learning targets. These are the things you really need to pay attention to, the main ideas of this particular section. I can use the mean and median for measures of center. And I can understand how differences communicate information about outliers. Now we'll get to what outliers are and that sort of stuff. You should be able to understand sigma notation. I know that is something that we dealt with in Algebra 2, but you need to remind yourself what it is, the good old summation notation, where we add up all a bunch of things, and it's just a shorthand version of that kind of stuff. And then the last thing you should note from this section is I can calculate weighted averages. That's the very last thing that we would do here. Okay, so let's dive into section 1-2. So sometimes when we use the word average, we don't refer to actually calculating anything. We talk about somebody's an average height person. But when you talk about the average height of a group of students, then you're actually measuring their height and you're calculating a statistic called the average or the mean. Sometimes it's referred to as the arithmetic mean. So you're familiar with finding the arithmetic mean. The median, that is another measure of center, and that's where you have to line up all the data in increasing order or decreasing order and find the one in the middle, or sometimes there are two in the middle that you have to average together. So, in this example 1 down here at the bottom of the page, it says, Wacky Widget Company has 15 employees. The jobs and annual salaries for each are given in the table at the right. The newspaper reported the average Wacky Widget worker earned $78,000. So the first question is, which statistic were they reporting? Was it the mean or the median? Well, if you line up all the data values in increasing order, obviously they're not lined up in the table that way. If you line them all in increasing order, well, there's 15 of them, right? And if you cut that in half, that gives you 7.5. There is no 7.5th value in the data set, so we have to round up and go to the 8th data value. So 1, 2, 3, 4, 5, 6, 7, 8. So 65,000 is the median, but they reported 78,000, so they must have been talking about the average. The mean was $78,000 because we know that $65,000 is the median for the data set. So do you think the Wacky Widget Company workers were, well, sure, they were upset because 1, 2, 3, 4 people earned more than $78,000 out of 15. That means 11 people earned less than that. Considerably less in most cases. So yeah, they were upset about that. Now, why is the mean here and the median way back here? Why is this the middle here, but this is a measurement of the middle and it's way up here? It's because of something called an outlier. And that outlier way up here, in this case, is the $380,000 CEO salary. And what that did was it pushed the mean up away from the median. So it's pulling it, and that pulling feature happens to the mean. So the median is said to be resistant. Okay, resistant, whereas the mean is not resistant. Okay, so to remind you about, if this number had come out to be a nice whole number, let's say it came out to be 7, then that means you have an even number of data values, and then you would have to average the 7th and the 8th data value together, starting from the bottom I know that finding the median is you can start from the top or the bottom because you're finding the middle value. But if you once we get into quartiles, which is a different animal, then you will have to know where you're counting from. Otherwise, you'll get the wrong values. Summation notation, just to kind of remind you about that. The big capital Greek letter sigma. If we want to, let me see if I can zoom in here. If we want to add up a bunch of data values, x1, x2, x3, x4, these all represent data values. Then we can say as I goes from 1 to 15 of x sub I. Well, these two things mean the exact same thing. This is just shorthand notation for this. So it's just saying that you're adding up, so you're going to insert a 1 for I, and then a 2 for I, and then a 3, all the way up to 15. It doesn't mean that the data values are 1, 2, 3, 4, 5, 6, 7. Okay? Because the data values in the last one were 24, 24, 27, 30, 30, 30, those kind of things. We could have also written that in a frequency table. I don't know if they have a frequency table listed on the other side. But a frequency table could have all of that written out, like you had 2 people at 24,000, 1 person at 27,000, 3 people at 35. So maybe that chart could have been abbreviated. We could have had salary and frequency. So we could have done something like this and said the salary was 24,000. There were 2 of those, 27 and 1 of those, and 30 and 3 of those. Okay, so hopefully you get the idea that a frequency table could have been used to illustrate the information of the 15 different employees. It doesn't mean that you just have one $65,000 salary. There are actually 4 people that have that salary. So try to make yourself a connection between this kind of table and this kind of information where you've written them all out, because that's a necessary thing in some situations to find the median. Okay, also just as a way to remind you about the mean of a data set, the definition, we know that the mean of a data set can be found by taking the sum divided by the total number of values. Well, take a look at this. Here it is, shorthand notation. Right there's the sigma notation showing you the sum of all the data values. And then under there is n. N represents the number of data values. See how they have the data values starting at x sub 1 and going through x sub n. So n represents the number of numbers, so to speak. Another way to write that is to, instead of saying dividing by n, they said multiplication by the reciprocal. That's an idea from junior high there. Dividing is the same as multiplying by the reciprocal. So these two things mean the same thing. They are just a fancy way to say the mean. So it says here a full parking lot has 46 cars. A piece of by number of people who rode in the ith car parked in the lot. What does this represent? Well, that'd be the sum of all the people, right? Each one of those data values, like P sub 1, is the number of people who were in that car. Well, that could be 2 people, or 3 people, or 5 people, or 1 person. Okay, but so this would be the total number of people. Use sigma notation to express the mean number. So if we have I goes from 1 to 46, so we've added up all the data values. How do we change that into, back this truck up a little. how do we take that total, right, because that's the total number of people, and we change it into an average. We divide by 46. Or you could say, 1 over 46 times the sum as I goes from 1 to 46, piece by. Because we know that dividing is the same as multiplying by the reciprocal. I know, pretty fancy stuff. Not really. Okay, so weighted averages. Here's a situation where they have letter grades and the point values attached with those letter grades on a 4.0 scale. It says Susan's grades are on her report card are shown in example 3. Well, so she got, in her keyboarding class, she got an A+, and in AP Calculus, which is obviously a little bit tougher than keyboarding, she got a B-. Well, they should be weighted differently. They should not be the same amount. So what we need to do is think about her total number of credits. Okay, so 6, 10, 16 credits, right, is how much she earned. But how many points did she get? Well, so 1 times 4 and 5 times 2.67 and 4 times 3.3. And you can see that they multiplied those things out and added them together, but there's that 16 coming into play in that denominator, so that she had a GPA of 2.42. You cannot simply just go through and add these numbers and divide by 5. That is not going to work here because they are not worth the same amount. If they were worth the same amount, then that little strategy would work, but it's not going to. Okay, and obviously here's the fancy notation for the same type of thing. Adding up all of the weighted scores, okay, and dividing by the total number of weights in order to get the total. And that's just the fancy notation for what we just did. Now you can think of them as frequencies. Okay? In other words, here's a different example. It says here, Alexis wanted to buy a ticket to a concert. She saw that the ticket prices were $20, $30, and $100. Okay? She wrote a letter to her concert promoters. She said an average price is $50. That's too much. Well, if you go through the math and start figuring it out, look, if the ticket price is $20 and there are 1,000 of those tickets, and $30 and only 500 of those tickets, and 100 and there's 20 of those tickets, well, then the average price ends up being $24.34. Not $50. $50 is found by taking 20 plus 30 plus 100 and dividing by 3. They're not weighted the same. You can tell from the chart they're not weighted the same. Okay, you can see from this chart, whether you're looking at the chart or you're looking at a graph, you can use these and multiply them together and then divide by the number of tickets, which would be 1,520. And you can see that the average price is $24.34. Relative frequencies. Last thing on our list here. A relative frequency means we're talking about percentages. Okay, changing things to percentages. Convert the frequency table and graph for the concert tickets to relative frequencies. So instead of saying 1,000 tickets, we said that a $20 ticket, there were 0.66 or 66% of the total number of tickets were $20 tickets. So they just changed each one of these into a percentage. You can even see on the chart over here, instead of saying 1,000 tickets, they gave these out as percentages. Obviously, these percentages would have to add up to 100% or to the number 1 since they're in decimal form. But the exact same thing happens when you take $20 times its percentage, $30 times its percentage, $100 and add its percentage, and then add them up. You still get $24.34. It's exactly the same thing. They're dividing before they add everything together. Whereas in the last example, they added everything together and